bring it back now.
Alright everybody, what is up? This is the Art Programmer and welcome back to my channel. In case you haven't noticed, I changed my channel name from the Art Programmer to Demon.exe. Anyway, today we are going to look at how to implement Firebase database with the Jetpack components like view model and live data. In case you don't know, Firebase database is a real-time database which stores data in JSON format. Here, real-time means that any change made in the database will be directly reflected on the client application. Vice versa is also true. So, in this tutorial, we'll make an application crew which will show a list of superheroes fetched from the Firebase database. Let's take a look at it. So, as you can see here, there's only one screen with a list of superheroes inside the recycler view. So, let's get started. First of all, clone this repository to set up the project. Link will be given in the description. After that, import it into Android Studio to set up the project. As you can see here, the layouts and stuff are already set up. In this state, the application is fetching data from this JSON assets file. You can go ahead and run the application to see how it works. Now, what we will do is to integrate Firebase database into our existing system. To do that, we have to create a Firebase project first. So visit the Firebase's console, then create a new project. As you can see, I already have created one. Next, you have to set up the Firebase project with your Android Studio project. You can Google about it. Next, head over to the real-time database section and create one. Select the test mode here. Now the database is created. We need to populate it with some data. So click here and select the import JSON option. Then navigate to the assets folder in the cloned or downloaded project and select this heroes.json file. This will populate the Firebase database with the contents of this file. Now, first of all, let's add the Google Services dependency at the project level. Then add the Firebase database dependency at the module level Gradle file. Then sync the project. Now we are all set up. Next, create a file under the data directory and name it Firebase Query Live Data. This file will contain the implementation of Firebase's data snapshot wrapped around the live data. So this way, any change in the Firebase database will be notified to the value event listener, which in turn will be notified to the live data. So in our fragment, we only have to listen to this wrapper live data and handle the cases accordingly. So let's take a look. First of all, we have some fields here. First one is query. This refers to the query that will be used to probe the database for data. Second is my value event listener, which is a private inner class that extends value event listener. It has two override methods, on data change and on cancelled. On data change is called every time there is any change in the database. So in this method, we set the value of this live data class to the newest data snapshot received. Also, this on cancelled is called if any error or exception occurs. So in this method, we set the value to null. We will handle the null case from the fragment. Now, next is a boolean remove listener pending, which is set to false. We'll later see its use. Next is a handler instance. Handler is a class provided by Android SDK. If you're not familiar with handler class, in short, it enables a runnable object to run on other threads or to schedule it to run in future. Next we have remove listener of type runnable. A runnable is an interface whose implementation is supposed to run on another thread. Next, we define our first constructor. It takes in a query object and sets it to the query field of this class. Next, we instantiate our runnable object. Inside it, we remove the value event listener from the query and set the remove listener pending to false. It will make sense later. In the next constructor, we are getting a database reference object, which is a subclass of the query class. So we set to the query field and do the same as we did in the previous constructor. Next, we override the onActive method. Now what we are doing here is to check if the value event listener is to be removed or not. If the remove operation is pending, then what we do is to cancel that operation. Now we are doing this because whenever our fragment goes through screen rotation, the fragment is destroyed and recreated. So every time the screen is rotated, our live data will go into inactive state and then back again to active state. This is beneficial in case of actual fragment destruction where the user closes the app, but in case of screen rotation, this will add extra network cost to the database. So what we are doing here is whenever the live data enters the inactive state, we wait for 2 seconds before we remove the database's value event listener to check if the live data comes back to the active state or not. If it does, then we don't need to remove the listener. So that's what exactly we are doing here. As you can see here, in onInactive function, we use the handler object to start our remove listener from 2 seconds now on. Usually, a screen rotation will be much faster than 2 seconds. This post delayed function of the handler class is used to schedule a given runnable to be executed after the specified time. Then we set the remove listener pending to true to state that a listener remove operation is in pending state and will be done after 2 seconds. In the onActive function, first we check if there is any remove listener operation is pending or not. If it is, then we cancel that operation because we are back to active state before 2 seconds, so we need not need to remove the listener. Else, this function is called for the first time, so we add our value event listener. In either case, we set the remove listener pending flag to false. So that's all for this class. Now, if you are enjoying learning, then make sure to like the video. Also, if you think my videos are helpful, then subscribe to the channel and share the video. Now, next, we'll set up the viewModel class to fetch data via Firebase database reference and return our Firebase query live data. So open the file and remove everything inside the class. Also remove the application object from the constructor and change the superclass to viewModel instead of Android viewModel. Now, first create a database reference object. So we are using the Firebase database class provided by the library itself, and then call its getInstance method. Then we call its getReference, which will return the database reference. Next, we create a Firebase query live data by providing the database reference that we just got. Next, we have this suspend function getList. It takes a data snapshot and returns a list of heroes. So first of all, we create a mutable list of hero. Then for every children of the data snapshot received, we add it to the list. Then finally we return the list. Also, if you see, this whole operation is done inside this with context block, which takes in a dispatchers. So we are providing the default dispatchers. These are part of Kotlin coroutines. As conversion from data snapshot to list might become a lengthy process, we don't want the UI to freeze. So that is why we are doing it in the coroutine. At last, we have a list of hero which is empty for now. Now finally we'll modify our fragment class to implement everything. So open the fragment class. First of all, we'll create some functions. First one is setup Firebase. Inside this function, we are observing our Firebase query live data that we are getting via the viewModel. If the data snapshot is not null, then get the list from the data snapshot via the getList function from the viewModel. We set it to the list variable from viewModel. Then we hide the loading text and call the setRecyclerView function, which will further set up the recycler view. Also, all these are wrapped inside this lifecycle scope.launch, which is also part of the Kotlin coroutines. In case the data snapshot is null, then we set the list to empty and call the navigate to retry function to navigate to the retry fragment. Next is the setRecyclerView function. Inside it, first we are creating the adapter object. Then we set it to the recycler view. Since we are using the view binding, therefore this binding object is used to refer to views. Next, we set the list to the adapter's list variable. Finally, we set the onItemClick lambda. We are simply showing a toast here. Next is this navigate to retry function. Inside it, we are setting the list to empty and then use the navigation components to navigate to the retry fragment. Now scroll back up and call the set Firebase function inside the onCreateView override function. So that's all for this fragment class. Now everything is set up. You can go ahead and run the application. Just make sure your device or emulator has an active internet connection. Then you'll see a list of heroes. Now if we change anything in the Firebase database, it will be reflected in the application. Let me demonstrate that to you. As you can see, our newly added item is showing here. So that is all for this video. To catch up till this part of the tutorial, clone the Firebase branch from the GitHub repository. Hit the like button if you learned something new. Subscribe to the channel if you find my channel interesting, and share the video if you think someone might be interested in this video. I'll see you guys on the next one.